Today we will be doing the exercise 12.1. Hello everyone, today we will be doing exercise 12.1 of the limit chapter. The link for the previous video related to the concept of limit you will find in the description below. So, if you are not clear about what is limit, you can watch the video and come back here for the exercise. Okay. So, the first question over here is limit of x plus 3 when x tends to 3. Since the denominator is 1, it is non-zero. If either the numerator or the denominator is non-zero, you can simply substitute the value, because when you are taking limiting values to 3, so we know we are going to take values smaller than 3 and bigger than 3, but the answer comes out to be the same like when you substitute 3. So, put x as 3. This can be done whenever either the numerator or the denominator is non-zero. So, the limiting value of this function is 3, a very simple one. Okay. So, this is limit x minus 22 by 7 when x tends to pi. Okay. Again, the denominator is non-zero, you can substitute x as pi, and remember that 22 by 7 is the approximate value of pi, it is not equal to pi. So, this is your answer. A similar question. Because the denominator is non-zero, simply put x as 1. See, actually when we say x tends to 1, we are using the deleted neighborhood of 1. But when the term is a when the function is such that it is not 0 by 0 form, you can directly put the value. So, we are going to substitute the value. Okay, so the fourth question is, now the denominator is not 1, but if you substitute 4 and c, it is non-zero. So, you can directly substitute the limit. Wherever x you write 4, so that is 16 plus 3 upon 2 is 19 by 2. Okay. Very simple. This questions of the beginning of the exercise are very simple. You just have to put the limiting value. In this question also, when you substitute x as minus 1, it is non-zero. You can directly substitute x as minus 1. The denominator is non-zero. First, we will always check the denominator. If the denominator is 0, we will check the numerator. If both are 0, then we will use the other limit functions, concepts and formulas and such things to find the limiting value. Okay. So, over here you can directly put the value, since the denominator and the numerator both are non-zero. Simple calculations. Okay, so now if you put x as 0, the denominator is going to become 0, the numerator also 0. You can see, put x as 0. It is 0 by 0 form, and when it comes to 0 by 0 form, you cannot directly substitute the limiting value. You will have to look for formulas and other concepts which will help to simplify this function in such a way that it no more remains to be 0 by 0 form. Okay, so in this case we are going to apply this formula, limit x tends to a for the function x raised to n minus a raised to n upon x minus a, which is n a raised to n minus 1. Now, I will take up a separate video on only this formula, and I will share the link in the description below. Okay. For now, we are going to take this formula. Now, you see, this is x a, xa and xa. When all of these are same, only the power here is different, then only you can apply this formula. So, to apply this formula, I need that, since I cannot change this, you may also apply binomial theorem and solve it, but I will write it in this way. I can write 1 as 1 raised to 5, so the numerator becomes similar, but then I need the same terms in the denominator. So, we can add 1 and subtract 1 to get it in the same way. Now, if x tends to 0, what will x plus 1 tend to? Adding 1 on both the side, you see that the limiting value is x plus 1 tends to 1. Okay. Now, you can compare. You see, that all the values are similar. What is the formula? N a raised to n minus 1, and that turns out to be 5. So, since x stands to 2, if you substitute 2 in this, you will see that it is again 0 by 0 form. You no more can substitute the limiting value directly, and we cannot apply the previous formula also, because it is not of the kind x raised to n minus a raised to n upon x minus a. Okay. So, it is a quadratic equation in numerator, in denominator. If on substituting x as 2, it is going to become 0, that means x minus 2 is the factor, right. Okay, so let us simplify and get the factor, the denominator being easier, let us do that first. And what about the numerator? Okay, so on factorizing you get this. Now, x minus 2 will get cancelled. Over here, some of the students, they simply do cancel it, but the concept behind this is that because x stands to 2 over here, we know that we are taking all values around 2, but we are not including 2. That means x is not equal to 2. And if x is not equal to 2, x minus 2 is not equal to 0. We can cancel only those terms which are non-zero. However, we are substituting x as 2 because we know that when you take different values around 2, your answer is going to come out the same as in what answer you are going to get for 2. That is the reason, right? Okay. So, we have cancelled this. Now, you can substitute x as 2. Just remember this in the back of your mind, that we are substituting 2 because for different values around 2, your answer is going to tend to that number, which is same for when you put x as 2. Okay. So, how much is this? 11 by 4. So, for quadratic questions or rational functions, including any polynomials, you can factorize and get the factor or the number which is making this value 0, so that you can cancel and get a non-zero numerator denominator to put the limiting value. Okay, once again, if you substitute 3 in the numerator and denominator, you are going to get 0 by 0 form. That means x minus 3 is a factor. So, factorize this, x square minus 9 and x square plus 9. Okay, I have applied a square minus b square identity. Same way over here, if you factorize this, splitting middle term. Now, since the limiting value is 3, we will have to further factorize this. Oh sorry, this is x square plus 9, okay, because it was x raised to 4. Okay, this is 2x plus 1 and this is x minus 3, the factors. X minus 3 got cancelled. Now, substitute 3 in place of x. Okay, so that is how much? 6 into 18 upon 7. 108 upon 7, right? Okay. In this one, if you substitute x as 0, it is no more a 0 by 0 form. Directly substitute x as 0, and that is b by 1, or rather b. So, this is again a question of the kind, if you see limit x stands to a, x raised to n minus a raised to n upon x minus a, which is n a raised to n minus 1, because 1 can be written as z raised to 1/3 minus, okay, and to get this. Now, if I want to apply the formula, I need this values to be same. Okay, fine, this is same. But then I also want upon z minus 1. So, I am going to divide the numerator and the denominator both by z minus 1. Now, limit is an operation which you can apply in the numerator separately and in the denominator separately. In the previous questions also we have done that. So, I am going to write it like this, and here we can now apply the formula. This one, what is it? n. Our n value is 1/3 in the numerator, a is 1 and 1 raised to anything is 1. So, you have 1/3 upon 1/6, which is 2. Okay, to the next question, as we see, if we substitute the limiting value 1, neither the numerator nor the denominator becomes 0. It is not 0/0 form. You can directly substitute x as 1. And since both the terms are same, it can be cancelled. The limiting value is 1. Okay, however, in this question, you see that when you substitute x as -2, it is going to be 0/0 form. Once again, you cannot directly put the limit. You have to simplify this first. And so we have, taking LCM in numerator. So, what's the next step? You can bring this x into 2 down. X plus 2 will get cancelled. Substitute x as -2 now because it is no more 0/0 form. So, the limiting value in this case is -1/4. In this case, if you substitute 0, it is 0/0 form, but for this one, we have a direct formula, which is limit theta tends to 0 sin theta upon theta is 1. If all these values are same, then the limiting value is 1. So, if the angle is AX, I need the denominator also to be AX. Okay, in this case, neither A nor B are 0. They are non-zero terms. Okay, so you want the denominator to be AX. So, in this case, what we have done is we have multiplied by A and divided by A. But there is also B, let it be there besides. So, it is Bx only, we have simply multiplied and divided by A. Now, since we have sin Ax upon Ax, which is like this, what should be the limiting value? It should be, if x tends to 0, then Ax will tend to A into 0, which is 0 only. Sin Ax upon Ax. This limiting value is 1. So, A by B into 1 will be A by B. Okay, we will apply the same formula over here. Sin theta upon theta. If the angle and the denominator values are same and the angle is tending to 0, then the limiting value is 1. So, over here, what is our angle for the numerator? It is sin Ax. So, we want upon Ax. Let us multiply and divide by Ax. In the denominator, we have sin Bx. So, we want to multiply and divide by Bx. Okay, x can be cancelled. What is the limiting value for this? Actually, we are actually taking limiting value for numerator and denominator both. So, what is the limiting value? It is 1 into A and 1 into B, because this value is 1 when the angle Ax tends to 0. So, if x tends to 0, we know Ax will also tend to 0. Same way, Bx will also tend to 0. So, we are having sin theta upon theta, which is 1, and sin theta upon theta again 1. Your angle is different, but the formula is the same, or the concept is the same. Okay. In this case, the angle is pi minus x. So, if angle is pi minus x, then the limiting value should tend to 0, so that we can apply limit sin theta upon theta, which is when theta tends to 0 is 1. So, if x tends to pi, what is pi minus x? Put x value as pi here and see, it is pi minus pi, 0. That means that if x tends to pi, we can rewrite this as pi minus x tends to 0, and we have sin theta upon theta, theta tends to 0. So, this value is 1, but besides this there is pi over here, rest all is 1. So, it is 1 upon pi. Okay, for this question, if you substitute x as 0, it is no more a 0/0 form. So, directly substitute x as 0. What is cos 0? 1. 1 upon pi will be the limiting value. Okay, in this one, if you substitute x as 0, it is going to become 1 minus 1, 1 minus 1. So, 0 by 0 form. You cannot directly substitute the limit now. So, you have to think of other ways to solve it, and since it is a trigonometric question, you can use trigonometric formulas, and we know that 1 minus cos 2x is 2 sin square x. So, this is going to become minus 2 sin square x, and what is the denominator? Minus 2 sin square x by 2, because if the angle is 2x over here, it becomes x. If the angle is x, it will become x by 2. Minus 2 can be cancelled, and as we know, applying the formula which we have done in the previous questions, sin theta upon theta when theta tends to 0 is 1. So, yes, x is tending to 0, but we need, because this is sin x upon x, we need here, okay, square I have taken. Same way here, sin x by 2 upon x by 2. So, we cannot simply write upon x here, you have to also multiply with the same term, x by 2 square. Since we have multiplied, divided with x square, I am multiplying with x square. Same here, x by 2, x by 2. So, yes, this is 1, this is also 1. What else? X square can get cancelled. So, I will put 1 value for this, x square is cancelled, 1 upon 1 by 4, 2 square, okay. So, that is 4. This question can also be done in another way. Let us see the other method. If we do not want to put the half angle formula, we can use rationalizing the denominator kind of thing, that is multiply and divide with cos 2x plus 1. Okay, we earlier classes we were simply rationalizing the denominator. Over here you can write rationalizing factor of the numerator also, so that whichever function is 0, we rationalize that. In case of cos minus 1, 1 minus cos, 1 minus sin, 1 plus sin, that kind of questions, or wherever there is root term. Over here, we will rationalize this, both. So, multiplied and divided with the same term, multiplied and divided with the same. Here there was minus, so with plus, minus, so with plus. Okay. So, the numerator term, when you combine this, we can get a square minus b square cos square 2x minus 1 square, and denominator cos square x minus 1 square. That is a very simple formula which we have studied even in our earlier classes. So, cos square minus 1 is minus sin square x, minus sin square x. This term will be carried down as it is. However, again here you have to adjust the term, but the only thing is you are not getting x by 2 and such terms. So, this becomes sin square 2x upon 2x square, because it is sin square. Okay, so, you have to take square common later on, sin square x upon x square. Same thing, you cannot simply divide and multiply with the simply divide. So, I am going to multiply with the same term, x square is going to get cancelled, this value is 1 and this is 2 square, which is 4. On substituting the limit, this is again 0 by 0 form, but however we know that for b sin x, I need to divide by x. So, we can divide each and every term with x over here, because x was the term which was making this 0 upon 0 form. That is why we can simply divide it with x. So, x gets cancelled, and here sin x upon x, when you put the limiting value, will be 1. So, substituting the limiting value, cos 0 is 1, and so you have a plus 1 upon b. When we put x tends to 0 for this one, it is 0 into sec 0, and sec 0 being 1, it is no more it is not a 0 by 0 form. So, you can simply put the value. In all these questions, wherever we are given condition, it simply specifies that whenever we are going to come to our answer, or whenever we are going to divide with A or B or something like that, it is not going to be upon 0 form. In here, when we substitute x as 0, it is once again 0 by 0 form. So we'll divide every term with x, because for sin ax I need ax, but that a can be multiplied divided by later on. But if we divide everywhere with x, those terms which were simply having into x will get or will become non-zero. Okay. Now here, because the angle is ax, we need a, so multiply divide by a. Angle is bx, we need b, multiply divide with b. And if you write the limit everywhere separately, it becomes like this. Okay, we have a here. Since the angle is ax, we can multiply with a. So x tends to 0, then ax will tend to a into 0, which is 0. Over here, oh, not here, over here, bx multiplying with b. Okay, now you can substitute the limit. Sin theta upon theta, when theta tends to 0 is 1. So you have a plus, limiting value for constant is the same, constant, same. And that's why you see you are given a plus b non-zero, because only then you can cancel this term. In this question, if you substitute x as 0, it becomes infinity minus infinity form. So actually it is 0 by 0 form only. Okay. If you would have written this or converted it to sine and cos, we have 1 upon sin x and cos x upon sin x, which becomes like this. If you put x as 0, you will get 0 by 0 form. So we have to simplify it, and like we did in one of the earlier question, you can simply rationalize this or put the formula. So I am going to multiply and divide with 1 plus cos x. So the numerator becomes 1 square minus cos square x, and denominator is sin x into 1 plus cos x. Also, we know 1 minus cos square x is sin square x. One of the sin x will get cancelled, and I think we can then substitute the limiting value. Let's put x as 0. Cos 0 is 1. So yes, 0 upon anything is 0. When we have questions where you can see x tends to a and x minus a, you can substitute x minus a as t. So in this case, we are going to put x minus pi by 2 as t. So what is x? Pi by 2 plus t. This is our substitution. Whenever we substitute, we should check what is the new limits. So when x tends to pi by 2, that means if you substitute x as pi by 2, t will tend to 0. Let's put all these values here. T tends to 0, 10 of 2 into x value is pi by 2 plus t, denominator is x minus pi by 2, which is t. Because the angle now is 2 into pi by 2 plus t, let's simplify this first. Pi plus 2t, and we know pi plus means it is third quadrant, because this value is pi. It is third quadrant. In third quadrant, 10 is positive. According to all sin 10 cos, 10 is positive. We are moving along the x-axis. 10 will remain 10. It's going to be positive. You have 10 2t. So the only problem now is you want 2t in the denominator. Multiply and divide with 2. Over here, if t tends to 0, then 2t will tend to 2 into 0, that is 0. Again, this is the formula, tan theta upon theta, like for sine, this is also 1. So this value is 1 and into 2. Limiting value is 2. So we have completed questions up till 22. We'll take up the remaining questions in the next video. I hope you like the video, you have understood the topic. Do like the video and subscribe to the channel. See you in the next video. Thank you.